Hey there, this is Math 7, Unit 5, Lesson 7, adding and subtracting to solve problems. So we're going to apply what we know about signed numbers to different situations today. Okay, so let's look at this first one. It says without computing, positive or negative, is the solution to negative 2.7 plus x equals negative 3.5, positive or negative? So without solving here, we can recognize that if I was to move this to that side by adding it over there, turning into an addition problem, I ended up with a negative 3 and a positive 2 respectively, okay? And so a negative 3 is going to be I have negative 3 and a positive 2. And in terms of which one has the greater absolute value, okay, the negative would be the greater one there. So it tells me in this case that I would end up with a negative solution because I'd end up with negative 3.5 minus a 2, I'd still have a negative solution there. For number 2, which of the following solutions to negative 2.7 plus x equals that? This is about rewriting things, right? So if I was to move this over here, I could say, for example, that x equals negative 3.5, all right, which is true for all of these. They all have negative 3.5, negative 3.5. This one does not, so we can kind of ignore that one for now, okay? And I have negative 3.5 there. So what about this other part? If I put it over here, I should have plus 2.7. That's going to be true for the basic ones, right? So a plus 2.7 works right there, whereas this is a minus. That's not going to work there. But what about this one? This is a minus a negative 2.7. This means I could also add the opposite, which means I'm still looking at the same problem. So this one also works just like that one, even though it's written with negative negative. All right, 7.2, phone inventory. A store tracks the number of cell phones it has in stock and how many phones it sells. The table shows the inventory for one phone model at the beginning of each day last week. The inventory changes when they sell phones or get shipments of phones into the store. All right, so on Monday they had 18, and then there was a change. At the end of the day, they had a change of minus 2, which indicates here that they must have sold 2 phones on Monday, meaning that when they started on Tuesday, they start with 16. On Tuesday, it looks like, gosh, they have probably sold 5 phones, which means on Wednesday they have 11 phones left to sell. On Wednesday, they sell 7 phones, that's why it's a minus there, it looks like, and so they're left starting Thursday with only 4 phones left. On Thursday, it looks like they sold 6 phones. Now that looks a little strange. How do you sell 6 phones if you only have 4? Well, perhaps they sold the 4 they had, and there's 2 people who said, I'll come back tomorrow and get them, I'm going to pay for them now. So they sold more than what they had, which meant now they're short 2 phones. Uh-oh, that's going to be a problem there. But on Friday, what we can see is suddenly they start with negative 2, and they end the day at 20, which means there must have been a delivery of some sort that probably came to get them up to 20 phones by the end of the day. Okay, so what do you think when the change is positive and negative? So a positive change, to me, would be an increase in their inventory, right? Maybe a new shipment came. A negative is going to be a decrease in their inventory, and maybe a sale was made, based upon how I'm reading the chart there, okay? So what do you think it means when inventory is positive? When inventory is positive, it means they have phones available to sell. They can sell things, right? They're available to sell, no problem. When it's negative, it means they're out of stock. Okay? So when the inventory side, when they're negative 2, it means they don't have phones to sell, they're short 2. In fact, they probably already pre-sold 2 to somebody else, and they got to get them to that person in time. Number 3 says, based on the information in the table, what do you think the inventory will be at on Saturday morning, and explain your reasoning. Okay, so Saturday morning. Well, here's Friday. We started at negative 2, and at the end of the day, they got a shipment of 20. Okay, so what we know is this. We know that they started the day at negative 2, but they added an additional 20 phones to their inventory. So we're going to put those things together to say that that means at the end of the day, or the start of the next day, they will have 18 phones. Even though they got a shipment of 20 in, they still had to give away 2 from the previous day's order, which left them with 18 to start the day with. So what is the difference between the greatest inventory and the least inventory? So our greatest inventory here on the chart is 18, and our least inventory is negative 2. Okay, so the difference can be, remember, positive or negative. And so our difference here is we have 18 minus a negative 2. Our first one minus our second one there. So our difference between the two, 18 minus negative 2, I'm going to add the opposite. So the opposite of negative 2 is a positive 2. So 18 plus 2 is simply 20. So my difference is going to be 20 between my greatest inventory and my least inventory. All right, activity 3, solar power. It says Hans family got a solar panel. Each month they get a credit to their account for the electricity that is generated by the solar panel. The credit they receive varies based on how sunny it is. This is true at my house too. I have these. In January, they used $83.56 worth of electricity and generated $6.75 worth of electricity. Here is electricity bill for January. So they have their charges and then their credit. So what they generated becomes a credit, and what's due is what's left over, right? 83 minus a 6 something gives you 74, right? That's your difference there. In July, they were traveling away from home and only used $19.24 worth of electricity. The panel generated $22 worth of electricity. What was their amount due in July? So the same idea here, we take the amount they generate, 19.24, and we're going to subtract it from it, the amount of electricity they generated, 22.75. Okay, so I can set it up this way. Another way I could set it up here is I could say it's 19.24 plus their credit. Okay, and the credit is going to be a negative number because it's a credit. So those are the same things, all right? This is the same way. This is subtraction, this is addition. I could turn that into a subtraction by doing what? Add the opposite. That would work too. So whatever way works for you is going to be just fine, however you want to set that up there. When I look at this, I see the signs are different, and so I find the difference. So $22.75 minus $19.24. Let's find the difference. We have 5, we borrow here, and we have 3. And I find the difference, but I want to keep the greater sign. This is positive, this is negative. Which number is bigger, 19 or 22? We'd say 22, so we're going to keep it negative, and we make it a negative 351. So they actually have a credit on their bill for July because they generated more money, more electricity than they used. Okay, that's how you want it to be. July is a good month. The table shows the value of electricity they used and the value of electricity generated each week for a month. What amount is due for this month? So these are weeks, and this is kind of at the end. So it's like they used, generated. So what's going to be their sum total, what's due? To do that, what we want to look at is we're going to find a total amount for each column. Okay, how much was used and how much was generated. So to find the total for this, we're going to add up all of these used dollar amounts here. And when we add this up, we come up with $77.40 was used. And in terms of what was generated, you come up with a negative $28.33. Okay, so those are my totals there for what was used and what was generated. In terms of what's due for the month, that's going to be set up again by $77.40. And I'm going to add to that there the credit of $28.33. I do the math there, and when I do the math, again, this is two different signs, so I find the difference, 77.40 minus 28.33. I know this is positive, that's negative. 77 is bigger than 28, so I'm going to end up with a positive solution. So let's do the math here real quick. We borrow, and we get 0.7. We borrow again, 17 minus 8 is 9, 6 minus 2 is 4, and it's positive, so we have a positive $49. So what's due is $49.07. What is the difference between the value of electricity generated in week 1 and week 2? Okay, the difference between 1 and 2. Okay, so we do the first value, negative 6.33, and difference means minus, and week 2 is negative 8.94. So we do negative 6.33 minus a negative 8.94. And again, this is going to be add the opposite, right? So now I have different signs, so I find the difference, 8.94 minus 6.33, and we have 162. When I look here, I have a positive 8, and I have a 6 and an 8. 8's bigger, so I'm going to keep it a positive value. So we have 2.61 for weeks 1 and 2. For weeks 2 and 3, we have negative 8.94. minus a negative 7.70. Okay, So this, sorry, go back over here. This means there was an increase of 2.61. Even though it's a negative value, we generated more electricity there. Here we can see going from 8 to 7, we should have a decrease there, right? We're going down in terms of the amounts generated. So if I go add the opposite and look at 8 compared to a 7, the 8's larger, so I'm going to keep it a negative solution, my negative solution. Let's find the difference. 8.94 minus 7.70. We get 4, 2, and 1, and we keep that negative there for my solution. Okay? And that's it for that sign, that one right there. Let's take a look at the next page. Differences and distances. All right, so we're going to use a coordinate grid today. We've talked before that a difference can be positive or negative, but a distance is always positive because it becomes the absolute value of something, right? It's how far away. A distance is always going to be measured by a positive thing. You can't have a negative distance, okay? Oops, that is. So positive or negative difference there. Distance is always going to be positive. So let's plot the points here. A is at 5, 4, so here's 5, and we come up to 4, and we plot A, no problem. B is at 5, comma negative 2, so we're going to plot B right here. C is at negative 3, comma negative 2, so we plot C right there. And D is at negative 3, comma 4, so we plot D right here. So there's my little grid there being plotted. So what shape is made if you connect those dots in order? We would have a lovely little rectangle. Okay. What are the side lengths of A, B, C, and D? Okay. Well, the side length of AB, 1, 2, 3, 4, 5, 6. So AB is 6. And then BC, 1, 2, 3, 4, 5, 6, 7, 8. So BC is 8. Which makes CD also is 6, and then DA is also 8. Those are my side lengths there. So what's the difference between the x coordinates of B and C? Okay, well my x coordinate of B x coordinate is 5, and my C x coordinate is negative 3. So the difference means I'm going to subtract those two things. So 5 minus a minus 3 is going to be equal to 8, right? So from B to C, I see the difference is 8. Notice if the difference is 8, what was the side length? The side length was also 8 there, okay? What's the difference between the x-coordinates of C and B? X-coordinates of C and B. All right, well, C and B, C is negative 3 and B is 5, and we do the difference here. We have negative, and then that means add the opposite. The signs are the same, so I find the sum, keep the sign the same, and we have negative 8. Okay? So, if I go B to C, I get 8. If I go C to B, I get negative 8. Remember we talked about before that that's that A plus B, or A minus B equals X, and then B minus A equals negative X. It's that opposite thing happening here. So how do the differences of the coordinates relate to the distances between the points? So the differences is we look at this. The absolute value of the difference is the distance. And that's the big thing here. The absolute value of the difference is the distance. So what's the absolute value of 8? It's 8. What's the absolute value of negative 8? It's going to be 8. That becomes our distance. So our distance is always going to be positive, or our difference could be negative or positive. Okay? So let's take a look then at tonight's homework. Tonight's homework begins with a review question. So there we go. Tyler orders a meal that costs $15. If the tax rate is 6.6%, how much sales tax will be on Tyler's meal? So to find a sales tax, we take the cost of the meal, $15, and we're going to multiply that by the tax rate. We have to turn 6.6 into a percentage. That means moving the decimal place over 2. So we end up with times 0.066 for our sales tax. That's 6.6%. And 15 times 0.066 gives you a value of 99 cents. So its sales tax will be 99 cents. Tyler also wants to leave a tip for the server. How much do you think he should pay in all? Okay, now this is going to be up to you how you want to do this. He wants to leave a tip. Okay, so we know so far he has to pay $15 plus 99 cents, so he's already sitting at about $16 for the bill. So whatever he adds onto this is going to be a tip. It's going to be extra. How much should he pay in all? A tip value can change. It depends on what you want to do. You could leave a tip of a 15% tip. It's kind of normal depending on the restaurant, and sometimes people go up to 20%. So it depends on what you're doing and kind of sometimes how the service goes. So you have 15% to 20% is what the value of the tip could be. Let's work it out for 15%, okay? And so if you did 15% of the bill, okay, you had a $15 bill times a 0.15, 15%, that would be adding $2.25 to the cost of the bill, okay? So you take your $2.25 and you would add to that your bill itself, which is $15, and you'd add to that your tax, which was 99 cents, right? This becomes your tip, that becomes your subtotal, and that's your tax, which altogether equals your final bill. And so $2.25 plus 15 plus 99 is going to be equal to $18.24, okay, is what you might do there if you did a 15% tip. If you did a different kind of tip, you can do that. You could do 20%, do the same thing, and figure out what that's going to be. In a video game, a character is healed at a constant rate as long as they're standing in a certain circle. Complete the table. Okay, time in a circle, 4 gets you to 100. Okay, do we have, it's a constant rate, so let's find out what our K, our constant proportionality, is going to be. That's our Y divided by X, right? So this is 100 over 4, which means our K value is actually 25. Okay, so let's complete the table then. If our K value is 25, what is 10 times 25? That would be 250. 3 times 25 is 75. And to go the other way, remember we do the opposite, we do the inverse, we multiply by the inverse, which is dividing by 25, okay, or multiplying by 1 over 25. So 1,000 divided by 25 is going to be equal to 40. Okay, so that's how that works. Again, going the other way, just remember how that works. Okay, how much higher is, comparing things here, 500 and 400. So order matters here. 500 minus 400 is going to be equal to 100. How much higher is 500 than negative 400? So we're going to subtract a negative 400. Signs are different. If we do subtraction, we add the opposite. So that's going to be a plus 900. Change in elevation from 8,500 to 3,400. Okay, change in elevation. All right, this is a great question because we can see we're high on a mountain up here, 85, and we're going down to 3,400, right? So if I do my subtraction like first to second, like it's been telling us to do, we have 8,500 minus 3,400, which is going to give you, in this case here, 5,100 is our difference between those. But because I recognize I'm here and I'm going down, okay, I have to say that this is going to be a negative value there. I'm going to add that onto there, which means I have to think a little bit differently about, okay, well, how does that negative get there when I'm doing subtraction? In this case, I'd have to set up a little differently, but for now, we'll just leave it like that. Just kind of visually it works there for you, okay? What's the change in elevation? Here, between that one and that one, the change in elevation, we have 8,500. Okay, and we're gonna add here a negative 300. Okay, and so our change in elevation is gonna be 8,000. Oh yeah, so negative 8,800. Now the reason that's gonna be a negative there is we're dropping down all the way to negative 300. We're going way down the mountain. So we gotta go from 8,500 to 0, that distance there, and then we're gonna go down another 300. So we have 8,500 here, another 300 there below 0. So combined distance is 88, negative 88. We're dropping down there. Okay, so just kind of pay attention to what's happening from a visual standpoint there. How much higher is negative 200 than 450? How much higher is negative 200 meters than 450? Well, that's interesting. So think of it here. Here's like a line, right? So here's negative 200, here's 0, and here over here is 450. So what is that difference from here to here to go from negative 200 to 450? I have 200 here, I have 450 there. That's a total of 650 is the difference between one to the other. So how much higher is that than that? It's actually lower. So we would say it's negative 650 meters higher. It's actually lower. Kind of a weird way to phrase that, but it's the distance is 650, but the difference is negative 650 because it's going down lower. So there's some strange wording on that one there, but hopefully you can figure it out with a picture. Table shows 4 transactions and the resulting account balance in a bank account, except some numbers are missing. Fill in the missing numbers. Okay, so we have 360 and then 360. So we're making a deposit here of 360 and the balance is 360. Then it looks like they do a withdrawal. They take some money out, 2250, and they're left with that amount. And then something else is going to happen here and they're left with this amount here. Well, that's a decrease, so we definitely had to change. Some money left the account. How much money left the account? Well, that's going to be the difference between those two values. So 337.50 minus 182.35 will tell me this value right here. So we borrow and we have 515 borrow and we have 51. So we know we took out a transaction of 155.15 to get me there. And then something else happened here where it looks like I'm left with a negative amount. So, and once again, we're taking money out and we're decreasing here. This transaction is going to be a takeaway. All right, so I'm going to do 182.35, and then I'm going to take away, I'm at a negative, in this case here I'm at a negative 140, or negative 41. So it's like this, 182 minus some value is going to equal a negative 4140. Okay, so when I subtract this value over here to over here, I end up with 2 negatives, right? And I find the sum and keep the sign the same. So I'm going to add a space here, so well, I can do it. We have 182.35, and I'm going to add to it 4140. So I have 57.3, 12 carry the 1, 2. So I'm actually going to be taking out $223.75. I'm going to make that negative because I need to make sure I end up with a negative solution. It's a withdrawal there. Okay? And our last one, all right, last one's interesting. Here we go. We have the historical rainfall average for Albuquerque, New Mexico in June, July, and August. This is a table. So this is how much it rains normally each of those months. Last June, only 0.17 inches of rain fell all month. So last June, we actually only had 0.17 there. What's the difference between the average rainfall and the actual? So average, this is our average here, and this is our actual there. So the difference between the average and actual, average was 0.67 minus our actual 0.17 is going to be 0.50. So our difference is 0.50. Okay, that's our difference. The departure from the average rainfall last July was negative 0.36. Okay, so negative 0.36. Okay, how much rain fell in July? So think of it like this. July was supposed to be 1.5, but instead of 1.5, it was off by 0.36. So we're going to do 1.5 minus 0.36, which will give us 1.14. Is how much actually fell in July. That's how much we were off that month there. So you can see so far on our chart, we've had less rain than we normally have in this situation. So you get to this point here, and it says how much rain would have to fall in August so the total amount of rain equals the average rainfall. Okay, so our average rainfall right here, or what it should be, our average rainfall should be at 3.74. That's what you want it to be equal to. So if we want this to also equal 3.74, we're trying to figure out how much rain would you need to fall in August to end up at 3.74. So to do that, let's take a look at what we've had so far. We've had 0.17, we've had 1.14. So far it has rained 1.31 inches of rain. So let's take that amount and let's subtract it from what we're looking for. We need 3.74. And we're going to take away what's rained already, what's come down. And what's left for August is we need 2.43 needed for August to make the average. That's what we need there. Okay, so that's what we need to equal the average. We need 2.43. What would the departure be from the average in August? Well, normally it's 1.57. So if it rained 2.43, we compare that to 1.57. The departure is that difference there. We would say in this case here the difference would be 0.86 more than the normal. And we would say it's a positive because it's going to be more than the normal. Whereas in B it was less, so we've had a negative sign there. Okay, that's it for the day. Hope that helps you out, and we will see you next time.